This is the introduction of the automotive brushed DC motor control circuit using TB9103FTG. We have developed the reference design of brushed DC motor control circuit used in automobile. This design allows easy control of the brushed DC motor with various protection functions by using a small-sized driver IC. The design information containing schematics, pattern designs, etc. is published as a reference design, so please use it for your design. In recent years, there has been an increase in the number of automotive applications that use brushed DC motors, such as back doors, sliding doors, power windows, power seats, etc. Therefore, there is a need for better solutions which can control these motors easily, safely and compactly. Thus, we have developed this reference design to provide such a solution. This is the board of this design. This design can work with the wide input voltage range of 8 volts to 18 volts. It can control one motor in H-bridge mode and up to 2 motors in half-bridge mode. The motor can be controlled using the onboard switches or an external MCU. It provides various protection functions like reverse connection protection, low voltage detection, etc. The board size of this design is 75 mm by 75 mm. This design can be used with 2 types of MOSFETs for driving the motors with different current ratings. With XBN7R104NC MOSFETs the rated current is 10 ampere. And with XBH3R304PS MOSFETs the maximum current is 20 ampere. This is the block diagram of this design. The gate driver IC TB9103FTG drives the MOSFETs that make up the bridge circuit and control the motor. This design can be controlled by 2 methods. In first method the input signals are set using the onboard switches and the fault detection is indicated by the onboard LEDs. In second method the input signals are controlled by the external MCU and the fault detection signals are read by the external MCU. The reverse connection protector circuit prevents the current flow when the polarity of input DC power supply is incorrect. It uses XBH1R104PS MOSFET as the switch to protect this design. 2 control modes are introduced here. In H-bridge mode, both outputs are used for one motor. Therefore, the motor can be rotated in both directions. In half-bridge mode, only one of the output is used to control one motor. In addition, up to 2 motors can be controlled independently by using both outputs. However, in this mode the motor can be rotated in only one direction. This design uses TB9103FTG, which is Toshiba's 2-channel half-bridge gate driver IC for automobiles. Its main features are 2 control modes which are H-bridge and half-bridge, dead time control and various fault detections, low power sleep mode, wide operating voltage range of 7 volts to 18 volts, and a small 4 mm by 4 mm package size. XBN7R104NC, N-channel MOSFET is one option for use in the bridge circuit. It has a rated voltage of 40 volts, a maximum drain current of 20 amperes, a typical on resistance of 5.6 milliohms. Its wettable flank terminal structure enables automated optical inspection called AOI. XBH3R304PS, N-channel MOSFET is another option for use in the bridge circuit. It has a rated voltage of 40 volts, a maximum drain current of 60 amperes, a typical on resistance of 2.5 milliohms. It also has wettable flank terminal structure. XBH1R104PS, N-channel MOSFET is used in the reverse connection protector circuit. It has a rated voltage of 40 volts, a maximum drain current of 120 amperes, a typical on resistance of 0.95 milliohms. It also has wettable flank terminal structure. The operation of this design in H-bridge mode is explained here. Set switches SW1 to SW5 to low to disable motor operation. Set mode signal to low to select H-bridge mode. Connect a brushed DC motor to terminals 1 and 2 of CN3 connector. Connect the DC power supply to CN1 connector. Set N sleep signal to high to wake up the driver IC. Set N1 signal to high to run the motor. Set N1 signal to low to stop the motor. Set N2 signal to high to run the motor in reverse direction. This design is ideal for controlling the brushed DC motors in automobile applications such as back doors, sliding doors, power windows, power seats, etc. This reference design supports the user to easily design an automotive brushed DC motor control circuit according to the target specifications. The design information containing schematics, pattern designs, etc. is published as a reference design, so please use it for your design.